Good morning, students. My name is Monalisa, PGT Chemistry, Kendriya Vidyalaya Barpeta, Assam. I'm here with my second video of the chapter Chemical Reactions and Chemical Equation. This is the first chapter of class 10 students. So, my dear students, I'm going to start this video. In my last video, I gave an introduction of chemical reactions, and the topic of this video is chemical equation and balancing of chemical equations. Okay, so let's start. Now in this video, first we will clear what does chemical equation mean. Okay, chemical reaction, I hope it is clear to you what is chemical reaction. Chemical changes are chemical reactions. Now, in the last video we have discussed about the chemical reaction of burning of magnesium to form magnesium oxide. So, if any of you want to convey this message to your friend that magnesium burns in presence of oxygen present in atmosphere and it forms magnesium oxide. So what do you want to say? What will you say to your friend? You have to say that magnesium burns in presence of oxygen to form magnesium oxide. Don't you feel that this is a long sentence to convey a message? So scientists thought that let's search for any way, any trick so that we can convey this kind of message and short. Okay, so basically we want to make this information shorter. The information of a chemical equation, we want to make the information of chemical equation, chemical reaction shorter. We want to make the information of chemical reaction shorter. Okay, so for this what can we do? We can represent the chemical reaction with the help of symbols and chemical formulas. Okay, what is this symbol and formula? These all you have learned in class 9. You have learned this, what is symbol and what is chemical formula. The representation of atoms are known as symbols and the representations of the molecules are known as chemical formula. And now the representation of chemical reaction with the help of symbols and chemical formula are known as chemical equation. Like this, if you write this Mg, capital M, small g, you know that this is the symbol of magnesium. This is the formula of oxygen, O2. So, you add this plus sign, that means magnesium and oxygen, these two are reacting. And in this right hand side of this arrow, if you write this MgO, this is again the chemical formula of magnesium oxide. So you can understand that these two react and they form magnesium oxide. So your information of this particular chemical reaction is complete now and you can write this in short. So chemical equation is nothing but the representation of a chemical reaction with the help of symbols and chemical formula. Okay. Similarly, you can write this H2 plus O2 give you H2O. That means hydrogen and oxygen react to form water. Okay. The same here, zinc, Zn, symbol H2SO4, sulfuric acid, formula. These two react, zinc and H2SO4 react to form ZnSO4. It is the formula of zinc sulfate and hydrogen gas. Zn plus H2SO4 react, zinc and H2SO4 react to give ZnSO4, zinc sulfate and hydrogen gas. Is this clear? Chemical equation is the representation of chemical reaction with the help of symbols and chemical formula. Okay, got it? Come to the next slide. Here you see in the last slide we took few substances. Few substances are reacting, and after the chemical reaction, with the chemical reaction, few substances are formed. Okay, few substances are reacting and few substances are formed. So those substances which react in a chemical reaction, that is the starting materials with which we are starting the chemical reaction, these are known as reactant. Reactant means those which are reacting. Those are starting material of the chemical reaction. And then the substances which are formed. The substances which are formed in a chemical reaction are known as products. We should know these two terms. These two are new terms to you. Reactant, those which are reacting, and product, those which are formed in a chemical reaction. These are very easy to remember. Now, balancing of a chemical reaction. What does it mean? Balanced chemical equation. We learned chemical equation, and now what is it? Balanced chemical equation. What does it mean? You see, here with this you can understand, you can get this information that hydrogen and oxygen react to form water. Very good. But how many hydrogen molecules are reacting with how many oxygen molecules, and how many molecules of water are formed, that we cannot understand. Okay. Now you see here in this chemical equation, it is written 2 molecules of hydrogen react with 1 molecule of oxygen, and in this chemical reaction they form 2 molecules of water. Okay. You see here the number of hydrogen atom is 2. Here also it is 2. Here number of oxygen atom is 2, but number of oxygen atom is 1 here. So if we follow this, that means 1 oxygen atom is destroyed. Of course it is not possible. 1 oxygen atom is destroyed. Can you recall the law of conservation of mass? Here we know that mass can neither be created nor be destroyed. So this particular oxygen atom is destroyed, which is not possible at all. Got it? But here you see 2 into 2. In 1 hydrogen molecule there are 2 hydrogen atom. So here 2, that means 2 into 2, 4 hydrogen atom. Here also you see 4 hydrogen atom. Here 2 oxygen atom. Here also 2 oxygen atom. That means the number of all kind of atoms, the number of all atoms in both reactant side and product side are equal. Then it is known as balanced chemical equation. Chemical equation gives you just the idea of the reactants and products, but it may or may not be balanced. In a balanced chemical equation, the number of all atoms will be equal in both the reactant side as well as in the product side. So this is an unbalanced chemical equation, this is an unbalanced chemical equation, and this is a balanced chemical equation. Similarly, you see here, this is unbalanced chemical equation and this is balanced chemical equation. You may get few examples where the chemical equations are always balanced, like here. You see zinc, 2 hydrogen atom, 2 hydrogen atom, 1 sulfur atom, 1 sulfur atom, 4 oxygen atom and 4 oxygen atom here also. So it is always balanced. Got it? What is balanced chemical equation? Now, the importance of a balancing of a chemical equation, or why do we need to balance a chemical equation at all? Why? In order to maintain the law of conservation of mass. The law of conservation of mass we need to follow for all chemical equation. If you consider this unbalanced chemical equation, you see hydrogen, the molecular mass, the molar mass is 2 gram here. Oxygen 2 into 16, you know, so 32. For H2O, for hydrogen 1 into 2 plus 16, so it is 18 gram. So you see in the reactant side the total mass is 2 gram plus 32 gram, that is what? That is 34 gram here. Here it is 34 gram, which is not at all equal with this H2O, that is 18 gram. So the mass is destroyed, which is not possible. Never. Law of conservation of mass is always followed. So this type of reaction cannot take place, can never take place. But here you see, for hydrogen, for one hydrogen it is 1 into 2, 2. So here the coefficient is written 2. So 2 into 2, 4. Here oxygen 16 into 2, 32. So if you add this, you will get what? You will get 36 gram. You will get 36 gram here. For H2O, for 1 H2O, it is 18. As it is written 2 H2O, so 2 into 18. That means it is again 36 gram. So the mass is equal. The masses are equal in both the reactant and product side. That means here in a balanced chemical equation, the law of conservation of mass is always followed. Am I clear? So to maintain law of conservation of mass, we need to balance all the chemical equations. This is a very important question. This is a very important question for your exam also. This is very important question for your exam, that why do we need to follow, why do we need to balance a chemical equation. Now, how will we balance a chemical equation? Okay, how will we balance a chemical equation? Try to understand how will we balance a chemical equation. Step by step, I am going to discuss this. Take one example. I took this example. Fe, iron, H2O, Fe3O4 and then H2. Okay. These two are the reactants and these two are the product. Okay. What do we need to do? Here, step 1. Step 1 is to balance a chemical equation. First, draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Your first step is make the box. Make the box. Okay. First thing is make the boxes around each chemical formula. Okay. Remember, this is not an essential step. I'm telling you, this is not an essential step, but initially you should do this because you can never change anything inside the boxes, because these formula are fixed. We can never change these formula. Got it? We can never write H2O2 in case of water. We can never write Fe6O8. We can never change it. So if you make the boxes, it will be in your mind that we can not write anything inside the boxes. Whatever we will write in front of the boxes. Whatever we will write in front of the boxes. We cannot write anything inside the boxes. But gradually, when you will be habituated with this balancing, then you may not draw these boxes, because for that timing it will be clear in your mind. Initially you should do this. Come to the next step. In the next step, make a list of number of atoms of different elements present in the unbalanced equation. Okay, see this equation. Fe, 1 in the reactant side and 3 in product side. 1, 3. Okay, hydrogen, 2 here, 2 here, both the sides same, 2, then also 2. For oxygen, here 1 and here 4. Okay, so we made the list. First step is draw the boxes. Second step is make the lists. Okay, here also I am telling this is not an essential part. This is the step for the starting. Okay, with gradually, when you will be habituated with this, you can make this list in your mind and you can go on. But initially you should make this kind of list. Now, why are we making the list? Because our main purpose is to make the numbers equal. We have to make the numbers equal. So, initially we are checking that where is the inequality. If you get the inequality, then you can make them equal. Now, third. Now, the thing is, with which molecular formula will you start? With which molecular formula will you start? It is convenient to start the balancing with the compound that contains the maximum number of atoms. Got it? That contains the maximum number of atoms. You see, here Fe only 1 atom. Here H2O, that means 3 atoms. Here Fe3O4, 3 plus 4, 7 atoms. Here 2 atoms. So we will start with that compound which contains maximum number of atoms. Am I clear? We will start with that compound where the number of atoms is maximum. So here it is Fe3O4. We will start with Fe3O4. Now, in this compound there may be many atoms. With which atom will we start? Here we have Fe and oxygen. With which atom will we start? We will start with that atom which is more in number. Okay, iron, number of iron is 3, number of atom of oxygen is 4. So we will start with oxygen. Am I clear? First you will find that compound where the number of atoms is maximum. Any kind of atom, total number of atom is maximum. You will start with that compound. Now in that compound, the number of atom which is maximum, you will start with that atom. So we will start with which atom? Oxygen. Now in reactant side it is 1 only. In product side it is 4. So how can you make them equal? Simple, very simple. If you multiply with 4, here it is 1 and here it is 4. So if you multiply this with 4, then it will be equal. Got my point? Got my point? First take that compound which contains maximum number of atoms. Then you see which atom is more in number. So here it is oxygen. Now you see the number of that atom in reactant side and product side. Now you choose that number. You choose a number to multiply with any of these. Here it is the reactant side. You may have to put the number in product side also. You put that number with which you can multiply the whole molecular formula, and these two will become equal. Okay, okay, understood? Now important note, very important note. Initially we told you that we cannot change anything inside the box. That means inside the molecular formula. You are writing 4H2. You are writing 4H2. You cannot multiply this. Okay, you cannot write simply 4 multiplying this oxygen, that H2O4, or somewhat like H8 and O4, or H2O and then this 4. You cannot write these all. You have to put the number in front of the molecular formula, and that is known as coefficient. The number which we are putting in front of the molecular formula to make the equation balanced, that is known as coefficient. Okay, you cannot change anything inside the molecular formula. Make this very, very clear. Next, whenever you are multiplying this molecular formula with 4, then this is not only multiplying with oxygen but also multiplying with hydrogen. Now the number of oxygen is 4, here also it is 4, very good, this is balanced. But now the number of hydrogen molecule becomes 8. The number of hydrogen molecule becomes 8. Now you have to make this equal. So in reactant side it is now 8, and in product side it is now 2. How will you make it equal? Simple. If you multiply this number with 4, this will become equal. So you have to put this 4 as the coefficient in front of hydrogen. So it is a chain like thing. You start with the compound which contains maximum number of atom, and then you check the then you check the atom which is more in number. Now you start with that atom, check initial number and final number, multiply with some suitable coefficient, and then gradually it will go on. Whenever you are changing this number, automatically number of hydrogen is changing, and to make it equal you have to change this coefficient again. Okay, if nothing is written, that means 1. So you are changing this from 1 to 4. Okay, so now hydrogen is balanced, oxygen is balanced. You see which atom is left. Which one is left? Of course iron is left. Iron is left. Initially it is 1, and in the product it is 3. So what will you do? You will multiply this with 3. So multiply this with 3. Okay, you multiply this with 3. Got it? Now check it once again, all are equal or not. 3 Fe, here also 3 Fe. Then I'm sorry, this plus should not be here. This is 4H2O. So 4 into 2, 4 into 2, that is 8. Here also it is 8, and 4 into 1 oxygen, so 4 oxygen, and here also 4 oxygen. Got it? Okay, so the number of atoms of all the elements are equal in both the sides. That means this is a balanced chemical equation now. Now what is the last step? The last step is writing symbols of physical states. Okay, this is also an important part of writing a balanced chemical equation, because if we don't write this, then we do not have any kind of idea about the state of that particular matter. As you know that chemical reactions may take place in solid state, in liquid state, as well as in gas state. So to inform completely, we should write the symbols of their physical states. And for this, if it is solid, you see here it is written clearly, if it is solid, then we will use S. If it is liquid, we will use L. If it is gas, we will use G. And if it is in the solution state, that means dissolved in water, for many reactions we take the solution of that material in water, and that is aqueous. Okay, aqueous medium means something is dissolved in water. For that we will use this AQ. So a complete balanced chemical equation is this: iron in solid form, water, steam here, gas, it is not liquid. You see, if it is not written, then normally you may think that H2O is liquid, and suppose you want to try this reaction, you will try the reaction with liquid water. But now if you see this, After this, if you want to try this chemical reaction in your laboratory, you will not use liquid water, rather you will use steam. So if you write this physical state, this will give you proper idea about that chemical reaction. Fe3O4, this is in solid state, and hydrogen of course in gas state. Okay, so understood? I am repeating the steps again. First, make the boxes, do not change the chemical equations in between. Then you check that compound which contains more number of atoms, here it is Fe3O4. Now check the atom which is in more number. First balance that particular atom, see the number of that atom in reactant side and product side, multiply with a suitable coefficient either in the reactant side or in the product side, and gradually proceed to the others. Automatically it will be a chain like system. Whenever you are changing one molecule, one coefficient, then automatically the other atoms will be changed and gradually you will move on. And finally you check the chemical equation again, whether all the atoms are equal or not in both the reactant and product sides. And the last step is to write the physical states of all the materials, that is all the reactants and products. Here few more examples. This is unbalanced chemical equations. Here you see, we will we will take that compound where the number of atoms are maximum. Okay, and finally we will balance it. This is the balanced chemical equation. Here unbalanced, and this is the balanced chemical equations. You follow the same methods which we followed just now, and this you can do. Okay, these are few unbalanced chemical equations here written, and these are balanced chemical equations. Okay, I have given few homeworks. You can easily do these all. Remember, in reactant side or in product side, you may have one or more than one substances. So don't be worried. In reactant side or in product side, it can be one substance or two substance or three or many more. Okay, don't become worried and follow the steps. You will easily solve these all chemical balancing. Okay, I hope you have understood these things. Now you solve these all, and we will come again with the next videos to continue this chapter. Okay, so try this and solve it. Thank you for listening.